Assalamualaikum warahmatullahi wabarakatuh. Today our group would like to present our final year project with the title Integration of Analytic Hierarchy Process, Entropy Measurement and Data Envelopment Analysis in the Optimization of Supplier Selection with the project code of P50M21, which is supervised by Puan Rashida binti Muhammad Rashid.
Before we proceed with our presentation, let me introduce ourselves first. My name is Husna Nazira binti Abdullah and I am the group leader.
My name is Nur Ilia Antasha binti Abu Hassan.
My name is Nur Atika binti Ismail. First of all, I will start by presenting the abstract. This study is to determine the best suppliers for an apparel company. There are 5 main criteria considered, which are delivery, capacity, warranty, cost and quality. In this study, analytic hierarchy process, AHP method and entropy measurement are being integrated with data envelopment analysis, DEA, in choosing the best supplier. Next, we move to introduction. For information, supplier selection is the process of a company find, analyze, and negotiate with the suppliers. The supplier selection process play a major role in lowering prices, improving profits, and the quality of goods.
Next topic is problem statement. Each supplier has their different advantages which make it difficult for the industry to select the best one. Moreover, these industries also consider 1 or 2 criteria as their preference in choosing the supplier, such as cost criteria, without realizing there are some other criteria that should be considered too. Therefore, there are several constraints that need to be concerned by them in choosing the best supplier. From the problem statement, 3 objectives can be derived from it. The first one is to obtain the weightage measurement for supplier selection problem by using analytic hierarchy process AHP and entropy measurement. Second is to integrate analytic hierarchy process AHP with data envelopment analysis DEA method and entropy measurement with data envelopment analysis DEA method for the optimization of supplier selection problem. Lastly is to find the correlation between the efficiency score obtained from analytic hierarchy process AHP and entropy measurement integrated with data envelopment analysis DEA by using Spearman's rank correlation coefficient SRCC to look for the relationship between both methods in selecting the best supplier.
Next, we will proceed to the scope and limitation. For the scope of this project is aiming to choose the best supplier by using the analytic hierarchy process, AHP, entropy measurement, and data envelopment analysis DEA method based on 5 criteria, which are cost, delivery, capacity, quality, and warranty. These criteria will determine which supplier is the most applicable accordingly to it. While for the limitation, this project only focuses on 2 methods in calculating the weight of each criterion, which are the AHP method and entropy measurement. Not only that, it just only considers 5 criteria, where it does not involve any other criteria such as financial position and others. Next is significance and benefit. The significance of this study is the study can prove that an integrated AHP, entropy measurement, and DEA method can be used to choose the best supplier to reduce costs and consequently increase profit. Meanwhile, for the benefits, since supplier selection is very important, the method used shows an improvement to the quality of products and also to the efficiency of the system and process to get more output for a unit of input. Next, we move to the literature review. According to Rajesh and Maligal 2013, the most widely known characteristic does not cost or price, but the supplier quality, followed by delivery, price or cost, and others are the most popular characteristics in order of rank to evaluate the supplier performance. Next, from Pobesco 2009, Sati has introduced the analytic hierarchy method AHP in 1980. Then, from Su 2014, Shannon and Weaver proposed the entropy weight method in 1947 as a weighting approach for measuring value dispersion in decision making. Lastly, DEA was developed in 1978 by Chance et al. Abdullah and Talib 2018 used the DEA approach to estimate the efficiency scores in the transportation manufacturing industry.
Methodology. This is our framework for this project. We will go through each stage in further detail. The first step is identify the problems and determine the objectives. Any difficulties, doubts, or areas of concern regarding supplier selection that requires thought and research are identified. A clear statement and objective to be achieved through this research is also identified based on the company's preference. The second step is collect the data. The question A's are prepared in Google Forms to collect the data. We send the questionnaires through the online platform, which is via email direct to the company of MBJ Next Trading. The data consists of the company's detail and suppliers' information based on 5 criteria. 3 criteria are chosen as inputs, which are delivery, capacity, warranty, while 2 criteria, cost and quality, as outputs.
After collecting the data, we will proceed with Phase 1 Analytic Hierarchy Process AHP. This method is an overall estimation hypothesis that relies upon the qualities and decision of individuals and groups. The first one is to formulate the pairwise comparison matrix for criteria. This step will contrast criteria rated to a basis in a characteristic pairwise mode. The respondent will ask to choose which quality they more prefer and give the rating based on the measurement scale of pairwise comparison as shown in the screen. All the cell values are allocated depends on the significance of the criteria from them and be placed in a matrix that called criteria matrix XATT. The criteria matrix will be calculated by using the formula as shown in the screen. After the criteria matrix is formulated, it will be normalized by using the equation as shown in the slide. All of the values obtained from it will be placed in the normalized matrix as shown in the screen. When the normalized matrix is obtained, we will calculate the weight of each criteria by using the equation as shown in the screen. The answer is WATT obtained just now will be written in the form as shown in the screen. After we calculate the weight of criteria, we have to check the consistency of the proposed pairwise comparison as shown in the screen. In order to use that equation, we have to find the consistency index CI as shown in the screen. The value of XATT and WATT are already obtained before this in step of formulate the pairwise comparison matrix and step of weight of criteria respectively. The answer obtained will be used in finding B by using the formula as shown in the screen. Since the total number of criteria in this project is equal to 5, hence the value of M is equal to 5. After value of B is obtained, then we will calculate the value of CI as shown in the screen. For the random index RI value, we will refer to the table of RI as shown in the screen. Since M is equal to 5, hence RI is fixed to 1.12. When both CI and RI is already obtained, we will calculate the consistency ratio CR by using the formula as shown in the screen. If the value of consistency is less than 0.1, then the model is acceptable.
The data collected also will be used in Phase 2 entropy measurement. The entropy measurement method determines the weight of the various criteria from the pair of matrices and is independent of the views of the decision maker. This method is also applied to evaluate the difference between the sets of data. The first step started by preparing the normalized pair of matrices based on a dataset of inputs and outputs. From the data collected, the summation of each column of criteria is calculated. Each of the criteria value in the column of the criteria is divided by the summation of each criteria column as shown in the formula of Nij. Then, all the values obtained from it will be placed in the normalized matrix, which is Bij, to display the result of normalized pair of matrices. After that is determine the entropy. In this step, every value in normalized pair of matrix is being used to determine the entropy value of each criterion by using equation Ej as shown in the screen, where M is the number of supplier, which is equal to 5. When the entropy value is obtained, the degree of diversification for each criterion is calculated by using the equation Dj as displayed in the screen. Lastly, each value of the degree diversification in each criterion being summated, then the total degree of diversification will be used in equation Wij as shown in the screen to get the weight of each criterion of entropy measurement.
After calculating the weight of criteria with 2 methods, the data obtained were then used to determine the efficiency using DEA. For this process, we use the primary model of the CCR input oriented with the Lingo software. The formula is as shown on the screen. This is an example of coding used in Lingo software to obtain the efficiency using DEA. The top of the coding shows the maximum Z equal to the summation of the weight of output times with the output values. Meanwhile, the middle of the coding presents the summation weight of output times with the output minus with the summation weight of input times with the input values less than equal to 0. The bottom of the coding shows the summation weight of input times with the input values equals to 1. The value of each weight, output, and input is determined based on the weight of each criteria obtained from the result of AHP and entropy measurement. Through this process, we will obtain the objective value that indicates the efficiency of suppliers. Sensitivity analysis. For sensitivity analysis, we use Payment Rank Correlation Coefficient (SRCC) to identify the relationship between the data solution of AHP and entropy measurement. The first step is to rank the weight of value of suppliers based on AHP and entropy measurement results. Second, calculate the difference between those methods and denote it as D. Third, square off the D and denote it as D square. Last, we apply the SRCC formula as shown on the screen. The last step in our methodology is the rank of suppliers. The rank of each supplier was determined based on the efficiency score obtained by using Lingo software. The highest efficiency of DEA value will be selected as the best suppliers.
After the methodology, we will proceed with the next topic, which is result and discussion. We will start with the result of weight of criteria. The table shown in the screen is the criteria's weight for AHP and entropy measurement for 5 criteria chosen. The highest weight of criteria for AHP is quality criterion with value of 0.4872, while in entropy measurement, the cost criterion has the highest weight with the value of 0.5396. From the table, we transform it into cluster bar chart as shown in the screen to make it easier to understand. The weight of each criterion for both methods are different from each other due to AHP is being evaluated based on human judgment, while the entropy measurement is being calculated directly from the data collected from the company. The highest criteria's weight is perceived as the criteria that be most prioritized by the company.
Next, we will proceed to the second result, which is the results of the efficiency of data envelopment analysis DEA. The result of the efficiency score for each DMU was obtained from the primary model of the CCR input-oriented DEA model. This result will use to determine the rank for each supplier by comparing the value of efficiency obtained. All the value of the efficiency and rank of AHP and entropy can be seen in the table shown on the screen. From the table, we transform into the cluster bar chart to make it easier to understand. Based on the chart, it is shown that AHP method has a higher efficiency score for each supplier compared to the efficiency score of entropy measurement. Supplier 3, which is Analysis Uniform Sendirian Berhad, is the most efficient supplier with the highest score, which is 1 for AHP and entropy measurement method. The second rank goes to supplier 5, which is Average Sendirian Berhad with values 0.8 and 0.7 scores for AHP and entropy respectively. Supplier 3, supplier 5, and supplier 1 have the same rank for both AHP and entropy. However, for supplier 2 and supplier 4, which are AAP Asia Apparel Sendirian Berhad and TLB Prince Corporation, both of these suppliers have different ranking for AHP and entropy measurement for 4th and 5th ranking. This is because both companies meet different weight required criteria obtained by the AHP and entropy measurement. Therefore, the weight of each criterion can slightly affect the efficiency of each supplier.
Next, we move to the result of sensitivity analysis. SRCC method is applied to look the correlation between the result obtained from AHP integrated with DEA and the result obtained from the entropy measurement integrated with DEA. The values of the SRCC calculation result can be explained as in the table shown on the screen. Since the SRCC value obtained for this study was 0.9, which is closer to 1, it is indicate that the positive correlation between AHP and entropy measurement. AHP and entropy measurement data solutions are acceptable.
In conclusion, this study has achieved our 3 objectives. For the first objective, we have identified that the value of criterion weight from AHP and entropy measurement methods are different. It can be seen from the highest value criterion weight for AHP calculation is the quality criterion, while the entropy measurement calculation is the cost criterion. In the second objective, we also optimize supplier selection by using DEA. For the DEA method that integrated with AHP and DEA method integrated with entropy measurement shows that supplier 3, namely as Alice's Uniform Sendirian Berhad, is the most efficient supplier. Lastly, for our third objective, we also found the relationship between both methods in selecting best suppliers. It shows that there is positive correlation between efficiency score obtained from AHP and entropy measurement with integrated DEA by using Spearman's rank correlation coefficient SRCC.
Since the scope of the study is limited in terms of criteria, which only 5 main criteria used to optimize the supplier selection process, thus the recommendation of this study is to use more criteria such as service, management, finance, as well as the number of suppliers to get wider results and better selection. Next, the study also may use other mathematical methods to be integrated with DEA method such as goal programming method or fuzzy methods.
Some of the reference used.
That's all from our group. Thank you.